All right, I'm gonna get started with number one. Let's see, let me make some space. All right, here we go. Number one. It reads, okay, there it is. -3 times the absolute value 2x minus 5 greater than or equal to -45. So first things first, write down the inequality symbol. Divide by -3 both sides. We end up with the absolute value 2x minus 5 less than or equal to 15. Hopefully you remember to flip it, yes? From there, is there anything outside the absolute value? No. At that point, we write two inequalities. One for -15, and we flip the symbol again, 2x minus 5. And one for +15, 2x minus 5 less than or equal to 15. +15. All right, let me solve. +5 plus 5, 2x greater than or equal to -10, divide by 2, x greater than or equal to -5. This side, +5 plus 5, 2x less than or equal to 20, divide by 2, x less than or equal to 10. So, let's graph that. Move up a little bit. There it is. All right. So we start at -5. It's a solid point because it has the equal sign. And of course, you can test 0 to see if you shade towards 0 and it's true. So we shade towards 0. From there, we go to 10. It's a solid point also. And again, I can test 0. Is 0 less than 10? Yes. So I go in that direction. So what does that show us? That it's a what? An and. Therefore, solution set of x such that -5 less than or equal to x less than or equal to 10. And there it is. And if you got that, you're good. From there, let me go to number 2. We'll go this way. For number 2, they ask us to find the sum and difference of these two numbers. Let's start with the sum. What does the sum imply, everyone? Very good. You add. So we have 2x plus 1 plus 3x minus 4. Since we're adding, is there anything multiplying outside the parentheses? No, so we just combine stuff. What is 2x and 3x? 5x. What is 1 minus 4? -3. There's our sum. Some of you multiplied and did I don't know what. For multiplication, of course, we use the product. That's multiplication. So we have 2x plus 1 and 3x minus 4. So 2x times 3x, 6x squared, 2x times -4, -8x, 1 times 3x, +3x, 1 times -4, -4. Bring down the 6x squared, combine these, -8x plus 3x, that's -5x minus 4. And that's our product. And we got that? Okay, good. Number 3, factor by grouping. This is where some of you got stuck. So what number divides each term other than 1? Nothing. So then we start powering. But this one now, look up, we no longer just write the 1 there because this one has a number as a coefficient. We'll remember to multiply the first times the last. That goes right there. The middle term goes down here. What factors of 6? 1 times 6, 2 times 3. So what 2 add up to 5? 2 and 3. So I'm going to rewrite this. 6x squared. Next one is positive 5x, but instead of that, I'm going to break it up into what? 2x plus 3x. Bring down the last term, plus 1. And now I can continue my grouping method. These two, these two. So, question. What number or numbers divides both of these terms? It's 2, but also each term has a what? X. That is correct. Now some of you are like, Mr. Q, I don't see it. Okay, let me show you. Look up. Like I used to tell my students, when in doubt, factor out. Let me show you right up above that. Let me zoom in. I'm going to break the 6 up. 2 times 3. Do you agree with that? Times, this one is x times x. Do you agree with that? I'm going to break this one up. 2 times x. Okay. What do both terms have in common? A 2 and 1x. So if we took those 2x out to divide the whole thing, what leaves us here? 3x. So we write 3x. Do we have anything left here? We can't write 0 or else this wouldn't exist, so it has to be what? Plus 1. All right, let me zoom out. So, with that said, plus what number divides these two terms? 1, and we're left with 3x plus 1. So, what's the same here and here? 3x plus 1, and what's left over? 2x plus 1. And these are my factors. Is it coming back, yes? I feel it. Because we're going to get to a unit where it involves polynomials and doing everything again that we did back. Woo. Woo. We good? All right, let's go to, bless you, number 4. Here goes number 4. It says graph. So what do we need to graph, everyone? X and f of x. -2, -1, 0, 1, 2. If we substitute that in here, what is -2 squared? 4, -1 squared, 1, 0 squared, 1 squared, and 2 squared. Let me graph that. -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. All right, let me write the rule. The rule is g of x equals, what is a? 1. Do we need to write it? No, Mr. Q. All right, good. What is b? 1. What is 1 over 1? 1. Do we need to write it? No, so we write f of x. Do we need the negative? Yeah, that's part of the formula. What do we substitute for h? +3. And then plus, I'm not going to write the plus because this one is a what? -5. Okay. Question. Is this rule compressing or stretching? Tell your neighbor why not, please. Let's see. Cindy. Compressing or stretching? Why or why not? did your neighbor say? It's neither stretching nor compressing. Why is that, Roman? Because it's one. What's one? And? Very good. When A and B are ones, that's why it doesn't compress or stretch. Very good. So at this point, do we need to add another column and do more computation? Can we do stuff with it from there? So you know what's going to happen to the original function? Allie, what's going to happen? What? Help her out, Caleb. To the horizontal. To the right, 3 steps, and then down 5. All right, so I'm going to take the point of origin, 3 to the right, 5 down. There it is. Next point, 1, 2, 3, 1, 2, 3, 4, 5. Next point, 1, 2, 3, 1, 2, 3, 4, 5. This point, 1, 2, 3, 1, 2, 3, 4, 5. And the last point, 1, 2, 3, 1, 2, 3, 4, 5. And that is our transformation. And have you got that? Yeah, we got these, yes? Now check this out. I wanted to point something out. Hopefully you already saw it, but I'm going to point it out just to make sure it's obvious. When we first started with functions, who remembers that in one of those exercises, I asked you to identify the maximum and the minimum. You guys remember that? So this one has a minimum, which is the lowest point. Is that correct? This is the minimum point. Does everybody agree with that? This is also known as the vertex. You guys remember that? Yeah? What's my coordinate for that point? It's 3, -5. Are we there so far? Okay, so watch. I'm going to do math magic. Tell your neighbor what you see from the rule to that. Noah, what do you see? That in the coordinates, what is what? That is correct, H and K. We can get them straight from this rule. Does everybody see H here? What did we substitute in here? +3. So here's a +3. What is K? -5. That's what we substitute in here. But here it is. So from now on, can we identify the vertex given a rule? Yes? All right. So let's say I gave you another rule for the same function, and I said g of x equals f of x plus 6 plus 2. Tell your neighbor the vertex of this one now. Vertex of that one. All right, let's see. Jasmine, what's our vertex? -6, 2. Hands if you agree with that. That is correct. People are like, why -6 if it's positive? Well, isn't the rule already have a negative in there? So what do we need to substitute in order to make it a positive? A negative. So it became what? 6. So therefore it's a -6. And the last part, the constant, is our K. Okay? All right. And last but not least, number 5. the easiest one, right? Step 1, rewrite it. Oh, sorry. Negative 4x minus 5 plus 5 plus 5. Y plus 5 equals negative 4x. Divide by negative 4. Y plus 5 over negative 4 equals x. At this point, we do the inverse, which is what? Switching the variable. So this is x plus 5 over negative 4 equals y. Rewrite it. Y equals x plus 5 over negative 4. And we need to rewrite it in function notation. The inverse of f of x, so that is f of negative 1, equals x plus 5 over negative 4. Okay, we're good? All right. All right, let's move on. Our home plate for tonight is only 2 pages. Pages 81 and 83 only. In your Cornell notes, like the objective, I can solve and graph absolute value 1 and 2 variable equations and systems. I know this is a little longer than the one on the whiteboard. Over there it shows only equations. All right. So we got a lot of stuff to cover and just in one set, but I want to make sure that I connect all the pieces before getting into the whole part or main part of the lesson. So I'm going to do a quick review of what you did for home play this week. Good. And it shouldn't take us long because you already saw the video, made it a math movie night with your folks, right? Here we go. So we're still in the overall of functions, yes? And once again, the objective is always over there in the whiteboard in case you missed it. All right, so we don't need a fair model. So copy this one, example 1 on your Cornell notes. Solve and graph 2 times the absolute value of 2x plus 1 plus the absolute value minus 6 equals 4. Solve and graph. I'll give you 45 seconds, yes? Is that good? Okay, 46 seconds. Copy and go. All right, let me help you out. Here you go. There you go. So you should have added 6 to each side. You're left with 2 times the absolute value 2x plus 1 equals to 10. So far so good. Divide by 2, divide by 2. The giant 1, absolute value 2x plus 1 equals 5. So far so good. Since you saw that there's nothing outside the absolute value, at this point we make 2 equations. One for negative 5 and one for positive 5. 2x plus 1 equals negative 5. 2x plus 1 equals 5. We solve. Minus 1 minus 1. 2x equals negative 6. Divide by 2. X equals negative 3. The other one. Minus 1 minus 1. 2x equals 4. Divide by 2. X equals 2. Am I done? No. What did it say in the video for you to do? Very good. In solution set, negative 3, comma 2. Very good. Graph. Negative 3, 2. Yes? All right. Move on. Number 2. Copy this one. Solve and graph. 3/5 times the absolute value 2x minus 4 minus 3 equals negative 3. Do this one together. Line down the equal sign. So what do I do from there? Miguel. Add 3, add 3. We end up with 3/5 times the absolute value 2x minus 4 equals 0. And some of you stopped right there and your noodle's trying to tell you no solution, but that is incorrect. You need to get rid of the 3/5 that's multiplying. How do we make this into a 1? By multiplying times the reciprocal, which is 5/3. Is that correct? Whatever we do to one side, we do to the other. So you're like, why 5/3, Mr. Q? Well, what is 5 times 3? 15. 3 times 5? 15. What is 15/15? A giant 1. There it is. So we're left with absolute value 2x minus 4 equals still 0. Is there anything outside the absolute value on that side? So at this point, we would make two equations, one positive, one negative. But in this case, we have a 0. So you never what we need to do. Victor, what do we need to do? Is there such thing as a negative 0 and a positive 0? No, there only exists one 0. So everyone, we only make one equation. That is correct. So plus 4 plus 4, 2x equals 4 divided by 2, x equals 2. Solution set 2. Graph 2. And have you got this by yourself? Yeah? All right. Example 3. Do this one by yourself. It shouldn't take you more than, what do you guys want? 35 seconds? 30 seconds? 30 seconds, copy that and go. You're like, what? Yeah, let's see. Minus 2 minus 2. We're left with negative 5 times x plus 1 equals 210. Divide by negative 5, divide by negative 5. Absolute value x plus 1 equals negative 2. Doesn't this look kind of weird? So first, let's check this side. Is there anything outside the absolute value? No. So at this point, we would write two equations, one negative, one positive, but this is already negative. That should give you a red flag. Therefore, you should ask, well, let's see what I have. An absolute value. What comes out of an absolute value? A positive number. That is correct. But this one, it says that it's equal to a what? A negative. Is that true? No, that is not true. Therefore, no solution. Nice. Yes? All right. Does everybody hear? Yeah? All right. So let's see. Let's recap what we saw over the weekend. So, who noticed, look up please, that after we simplified, we left the absolute value by itself, it was equal to a positive number. You guys see that? How many solutions did we get? 2. All right. Next, after we simplified this one, we left the absolute value by itself, it was equal to a what? 0. How many solutions? 1. Next one, when we simplified absolute value by itself equal to a negative, how many solutions? No solutions. So if we recap, we can say that there are either 2 solutions, 1 solution, or no solutions. So therefore, Audrey. Oh, it's nothing. Mel, when is it 2 solutions? When an absolute value equal to a positive. Cassie, how about no solutions? Equal to, oh, 1 solution equal to 0, yes. And everyone, no solutions when that's equal to a negative. That is correct. We got this, yes? All right. So, also, you're going to get one of these in the home plate. I'm just revisiting this one. We covered already this one when we first did absolute value about a month ago. And I did it but with the Coronado Bridge. You guys remember that one? Yes, Mr. Q. All right, good. So check this out. It says, a support beam for a building must be 3.5 meters long. It is acceptable for the beam to differ from the ideal length for 0.003 meters. Write and solve an absolute value equation. So check this out. Don't write this down. This is just to remind you. Remember that I said write the absolute value x, then minus, and then the other number goes out here. You guys remember that? So check this out. So which number should go here? So you need to remember, this becomes what? Negative, and this becomes positive. So which of these two becomes negative and positive? The one that says it differs. How much does it differ? 0.003. That goes right there, which means the distance goes 3.5 right there. So what's the key idea on this? Number one, that you never change this. This is always a negative, x minus that. And the one that goes over here is the one that differs. It's either plus or minus. Okay? All right. Questions, comments, autographs? No? All right. So today, before we move on, look up, please. And you're saying, but why do we write it like this, Mr. Q? Well, let me rewrite this. G of x, a f of 1 over b x minus h plus k. What if I gave you the rule g of x? Oh, sorry. Can you guys see from there? No? What if I gave you the rule g of x equals absolute value x minus 3 plus 6? Can everybody see what's happening now? Say never what's happening. So you're like, I think I missed it. All right, let me remind you. Absolute values, the graph looks like this. Is that correct? So let's say I gave you that graph, and I asked you to do this transformation. Tell me what you need to do to the original function. We good? Come on, people. I know it's Monday, but let's go. Cindy, go. Pedro, what do we do to this original function given this? I'm sorry? Right? Hands if you see it. Okay, Jasmine, go. Right 3 and up 6. That is correct. All right. All right, so here we go. Last review. Graphing. Y equals 2x minus 5. Don't copy this. It can be written as f of x equals 2x minus 5. Where do we begin our graph? At negative 5. What is the slope? 2 up, 1 to the right, 2 up, 1 to the right, 2 up, 1 to the right, and there's our graph. What kind of slope? It's a positive slope. That's why it's going up. How about this one? Y equals negative 3x plus m. Where do we start? At positive 7, and it goes 3 steps down, 1 to the right, 3 steps down, 1 to the right. What kind of slope? Negative. That's why it's going down. Look at this one. Y equals 3. What's it missing? The x. That means it has what kind of slope? Very good. 0. So if it's missing the x, it's 0 slope. That means it's a flat line going through what? Y equals 3. There it is. And lastly, x equals negative 6. So you know the graph for that one. If it's missing the y. Very good. Straight up and down. And I can write it as f of y equals negative 6, and it goes through negative 6. All right. Get your big graph paper, please. Copy this one. Example 6. Solve and graph the system. 2 times the absolute value x minus 5 minus 4 equals 2. Just copy that. Steven's like. All right, here goes, guys. Some of you are like, Mr. Q, this looks so easy. If it was focused on one variable, but now that we're focused on what? Two variable, and now it's called a system. Now, writing utensils down, look up to the screen. Now, I'm going to break it down because the book does not show you how to break it down. They just give you solve the system and graph it. Okay, here it goes. First thing, I wrote solve the system. The book doesn't say that. It just says solve and graph the absolute value function. So check this out. As soon as I see system, I do this. So that 1 became 2. And you're saying, I still don't see it, Mr. Q. Okay, let me put it in the terms that we did about a month ago. Let's say this replaced what variable? Y, and this one also the variable y. Do you agree with that so far? What if I said solve this system? Some of you were like, well, I can substitute. What is y here? 2. So here, instead of writing y, what do I write? 2, and I end up with, you guys see it? But now I'm going backwards. Instead of writing it like this, I'm going to write it as 2 functions. Okay, so write those 2 functions, please. Let me get the y out of the way. Does everybody see y? All right. So first, I rewrote the system. Second, it says graph it. Can we graph this one? Yeah, tell your neighbor what this one will look like, please. Horizontal line, yes, straight line going through what? 2 of y. Sketch that one, please. I'm going to do that in blue. There it is. Make sure you stretch it all the way through your coordinate plane. Okay. All right. Next, we need to graph this one. You're like, how do we do that, Mr. Q? Well, we make a table. X, f of x. -2, -1, 0, 1, 2. And remember when we did quadratics, we would do what? -2 squared, and we would write it here, right? But now it's not squared. What do we have to do with the 2? Substitute it in here. So I'm going to zoom in so you can see it. I'm only going to do maybe 2 of these, but you should be able to see it after that. Here we go. What is my first value that I'm going to substitute in there? -2. So here instead of x, what do I write? -2. I bring down the 2, absolute value, -5, absolute value, -4. What is -2 and -5? -7, absolute value, 2 times that, -4. So at this point, what is the absolute value of -7? 7, and the 2 is doing what? Multiplying. So this is 14 minus 4, which is 10, and that goes right there. Okay, that was for -2. Let's do one more. I'm going to substitute now -1. So what do I write? 2 absolute value and -1. So what is -1 and -5? -6 absolute value, 2 times that. What is the absolute value of -6? 6 times 2 minus 4. What is 2 times 6? -4, 8. That goes right there. Do I need to show the rest? Can we do it in our noodle now? All right, let's see. Let's try our noodle. I'm going to substitute 0 in here. What is 0 minus 5? Negative 5. What is the absolute value of negative 5? Times 2 minus 4. That goes here. Next one. 1. What is 1 minus 5? Negative 4. Absolute value of negative 4. Times 2 minus 4. And the last one, you should be able to see a pattern by now, yes? Which is 2. All right, let's plot those. We got negative 210, negative 18, 0.6, 1.4, 2.2. You're like, okay. Don't sketch your line yet. Check this out. What kind of function are we looking at? Absolute value. What does that look like, everyone? A V. Do you agree with that? Is this starting to look like a V? Look at this. I'm saying this one, not the blue one, just the black points. Kind of, yes. But do we know how to find the vertex of that function? Look at this. Tell your neighbor the vertex of this function. Anthony, go. From this function. Close. 5, negative 4. Hands, do you agree with that? That is correct. So let's plot our vertex. 5, negative 4, which is right third. So what does that mean, Mr. Q? Well, it means that half of our function is here. But what does that do, Mr. Q? Well, if this is the vertex, it creates a mirror right here, doesn't it? If it creates a mirror, tell your neighbor the other 2 points at least that we need on this side to make our function, to sketch our function. What are the other 2 points on this side? Other 2 points. Okay, let's see. Can you give me one of those points? Big, yeah. Help her out, Rosina. What is it? 7, 0. Okay, I see what some of you look at, guys. Does everybody see that? They're saying that here's a point. There should be another point right here. You guys see it? Yeah, I'll take that. That's fine. But do you see the other obvious one? What is it? 8, 2. That is correct, which is right there. And one more. What would be the next one? 9, 4. All right, so let's sketch our other half of the function. There it is. Are we done? All right, so let's see. Instructions were solve and graph. Did we graph the system? We graphed it. Have we solved it? By graphing, yes, but you guys still haven't identified. Let's see if you remember from the other day that we did systems. What is a solution to any systems of equations? Talk it over to your neighbor. See if they remember. What is the solution to any system? Very good. The point where both graphs intersect. Very good. Solutions. I'm going to write x equals 2 or x equals 8. The point where both graphs intersect. Does everybody see how g of x intersects f of x right here? Yes? Okay, good. Here goes the process one more time. What is the first thing we did? We rewrote this as a system. Graphed the first one. Graphed the second one using a table. Plotted our points, but then we needed the what? The vertex in order to sketch our other 2 points. Okay? So we will think ourselves like we are with these. 4 5s, 4 5s, 4 5s. Okay, not bad. All right. So your home plate for tonight is on pages 81 and 83 only. There is tutoring today. And by the way, those of you that don't see the vertex, here it goes. Let me highlight it, or I'm going to use colors. What did we substitute in here? That's how we get our x value or our h. And what number is our constant over here? That's how we get our k. Okay? A good one, guys. Your home plate. See you guys tomorrow. Bye.